Wow. How's that, huh? It's so awesome. Like, Tejas is one of my best friends in this, in general, in life. And so it's so awesome to be introduced by this guy. And you see the amount of energy he already brings to the stage this early? I'm not joking. He's like that every time, anytime. He's always on. It's awesome. I take great inspiration in that. But yeah, OK. So we're here to talk about signals. He already mentioned that to you. And as most of you, they're from this lovely, beautiful city, probably be wondering, I need to say to you, Bocsi, I'm not Hungarian. My name, I thank you all, your history for this name that I like so much, but yeah, I cannot speak Hungarian, though I'd love to learn. Sounds like a really good language, and I'm having fun watching TV and not understanding anything. But yeah, who am I? Besides a guy with a Hungarian name from a place that doesn't have anything to do with it, I'm a DevRel lead at Crab Nebula. Some of you met me before in the workshop. We talk about Tauri, so I do a lot of stuff with Tauri, and I also work in the SolidJS team. And I'm a GDE for the web technologies. After this talk, if you cannot catch me in the hallway and you want to still talk about something, I'm always up for it. Because naming things are hard, I end up switching handlers in pretty much every social media. So I create these handy shortcuts with my website. So Atila.io, any social media you can find me. I love to connect. But yeah, we have some ground to cover. So let's jump into it. So the question we're here to answer is, are signals worth the hype? And yeah, thank you. Yeah, OK, so jokes aside, as I mentioned, I'm not trying to read that. I'm kidding. I'm here to The point of this talk is actually so you can make this conclusion, if they're worth the hype for you or not. Because one thing that I'd like our community to stop having is some kind of herd mentality where somebody puts a microphone on or records a video or sends a tweet, and we just agree with them because they seem confident in what they're saying. So the point of this talk is actually not convincing you to use signals, is showing how signals work and what that brings to your applications. And then you can make a decision about if they are good enough for you, if you would like to try them. But before we continue, this is Nova, and I'll put her right here. And she's here because I have a little game for us to play during this talk. So she's going to be around my slides randomly. And if you're interested in having her as a flatmate, you count the amount of Novas you see on my slides. And then when this talk ends, you can send a tweet to me and to my company with a number, a little bit lower than that's going to be, and hopefully the hashtag of the event, or you mention the event, so we can get that social media action as well. And then you can take her home. So, good? So let's get started. First of all, then, what are signals? And before we talk about it, what are signals, how this implementation of the observer pattern works, let's talk about API architectures, because the observer pattern is a way of implementing two, actually, of these architectures. And with that description, we can then create signals. And they are agnostic to any language. The implementation we're going to be seeing, of course, is JavaScript, because it's JavaScript conference. But they exist since the 80s or so. So the first architecture we have to talk about is pull. And then what happens is that we have a client that's going to send a request saying, OK, I want data. And you have the push, where you have the event that's going to be sent. Those are the two architectures. The way that the pull works is you have the client, the component, and you have the data source in this case. And the pull system, the component needs to say, OK, got an update? Nothing happens? No. Got an update? No. You got an update? Yeah, I do. And then you get the update. The way the push system works, it's a little bit different. So the data source has data, and then it just pushes up to the client. So as you can imagine, these two have some trade-offs. And it depends on what kind of API you need to build. If you have pull, you need to implement a polling system that is going to be in a certain amount of time fetching for this new data and making sure that the data can pull this data up. And then once the data arrives, you need to have some way of refreshing your entire everything that depends on that data. And the push, the data knows where it should be, and it just comes in. And that brings another kind of complexity. You don't need to set a polling system, but you do need to handle something that's called back pressure. Because if the data source updates too often and sends this data to your client too often, this means that your client can be overwhelmed. Sort of like drinking water from a hydrant. It's not comfortable. So you can miss updates. You can crash your system or something like that. Because of that, there's something that some people call push then pull. I prefer push-pull, but for this particular slide, it's easier when we say it like that because it gives you like the right mental model in the very beginning. So you have the data source and the client, and then this data source is going to say, I got an update. And then, because it communicates to the client can then schedule whenever it's comfortable or whenever it's possible for it to handle this update. And then whenever it's ready, it says, OK, send me the update, and I'll do it. This is a way that you can prevent. You don't need to implement a polling system because your data is able to communicate that it has changed, and you don't need to handle back pressure because you have a scheduler for that. So you're basically implementing a stack, like the last one in is the first one out, and so on. So to the ones of you that are familiar with with different frameworks, and you already used some of them, I imagine, pull, just to make a practical example, is use state, in this case, for React. And push then pull are the signals, in this case. Like, yeah, all the implementation of signals are push and pull at this point. So the push and pull has, for us to better understand, it has some requirements that, like, on a very, very nutshell, in a very simplified way, there's two capital rules of a push and pull system, or signals, for them to be considered useful. The first one is efficiency. So the signal needs to execute the least amount of work possible. That's why we call it fine-grained reactivity. So the updates are surgical. It's going to change only what requires change. There's no like whole teardown. There's no like re-renderings and stuff like that. The second thing, and that's the most important, is glitch-free. Because in a lot of push systems, or like in a lot of systems in general, there's a problem where you have something called state tearing, where a piece of your application is going to have an up-to-date data, but another piece lagged behind for some reason. Either because there was too much back pressure and it could not handle, or because the polling system failed. It can have many, many reasons, but this happens. If you don't remember, if you're having a tough time picturing it, imagine when you go to GitHub. Like, everybody here uses GitHub? Yeah? Yeah? Awesome, yeah. So you know GitHub? Either you do open source or not. If you work with that, you probably notice whenever you go to a pull request and you're code reviewing it and you merge it, you merge the pull request and then you have a list of 5 remaining pull requests, but that little navigation bar on the top still shows 6. That's state tearing, because that little counter did not update to the latest state. And that's a glitch in this case. So a push and pull system needs to prevent that from happening. Otherwise, it's hard to reason about, it's bad UX, and so on. So for us to recap, you have the push and pull as an API architecture. Signals are an implementation of that. And as a consequence of this, we get fine-grained reactivity. My question then to you is, for us to talk about is, can we achieve fine-grained reactivity without signals or without a push and pull architecture? Let's take an example, for example. An example, for example, is great, yeah. So let's take an example. We have this component. It's very similar to actual code, but that's totally not the point. Because the way the code looks doesn't matter. What's important is that I'm considering this as something that has a virtual DOM. It's a pull system in this case. So you have your data is unaware of where it is, and you have a rendering engine that's going to handle it. So let's render this button. And I want you to reason with me about what's going to update whenever what's going to change whenever I update this rendering. So we have the little paragraph at the bottom that shows the current count. And then if I click this button, what's going to re-render, what's going to change, what's going to be updated is the whole thing, because the data, the system is unaware where the data is. So in order to prevent the glitch, the system needs to tear down the whole thing and then it starts it over, because then if it tears down the whole thing, they have only one certainty, is that whatever is coming up to date. So that's the point of the whole re-rendering stuff that we keep seeing, and that's why there are some mechanisms in place to make sure that you've had double renders in development mode, for example. They still show the same thing because you need them to be deterministic. Otherwise, you have a glitch. So these are all mechanisms that a pull architecture needs to have for you to be able to write applications that are glitch-free. On the other hand, if we have something as signals, and you can see that there now my paragraph has a parenthesis, which means it's a function call because it's an accessor. That means this value doesn't exist in my, like at that particular time. What happens is that every time I'm going to show this thing, that count is going to bring the current value, which means that with this, my system is able to know where the data is. So if I render it and I update the count, that's the only thing that changes, because my data can tell, okay, count updated, and then it knows exactly what are the method it needs to run whenever count updated. It needs to run the count function, and then the count function runs again, and then I can have a surgical update. So that's the point. But I can do whatever I want with slides. So let me show you in the real world. So here I have this thing here. Yeah. So so here we rendered everything that we got, and this is yeah. Why did I close my console? I shouldn't have closed it. So we have this little component over here, and I rendered all my apps, which is expected. And now, if I increment, I'm going to re-render the things, because I have this button, and the button has some nested stuff, but the data lives on my wrapper app. It's going to trigger an update where the data is. So everything from that data down needs to be teared down and rendered again, which is why every time I do something like this, increment, I have all of them rendering once more. And the thing that we do in this case to make it more performant is something called memoizing. Memoizing is a technique that would allow us to prevent unnecessary work from happening again. So what we say is every app that depends, every component that doesn't depend on that particular data doesn't re-render. And for that, we can have compilers to do that, because then to automate this kind of stuff. So, for example, you have, like, if you use something as awesome as Vite, you can just have a plugin here that's going to use a certain compiler that's going to understand how your code is working and automatically see which components are depending on this and auto-memoizing or not. The problem, though, is that if you still write code like this, and you're hoisting your data, you still are doing, you cannot memorize it because the data is updating on the top, and you need to tear down because you're passing those values to every single component because they are using such values. So regardless if it's memoized or not, you still render the whole thing. So it's not efficient. It's not fine-grained. Though it might save you in like a lot of different cases, it's not. So here we have an implementation that uses the push and pull. It uses signals. And the first render, obviously, you render everything. And then if you clean it up, you can, oh, that's so tiny. I can click, and I can update as much as I want. And the only thing that actually renders again is my onClick, which is having this console log that's saying it's clicked, while not rendering the do work thing that just does all of them. So again, if I re-render, if I reload again, I have all of them. And that's essentially the difference between memoizing or memoizing against having it fine-grained by default. So they're not the same, which makes me extremely happy because the little meme that I did last year holds true, where, yeah, if you do signals, you can ditch memo for this kind of rendering stuff. So memo as a concept, as an idea, is to prevent you from running heavy tasks, is not to optimize little tasks that you don't want to render again. For that, you just need better better defaults or better handling of your data. Which brings me to my little first rule of DX, where if you have, like, a framework is responsible for giving you good defaults. It's going to give you the whole railway where you can define, you can then be able to write good code, and as a consequence, you have good UX. If it is too hard to write good code in a framework or in a tool, then it's kind of failing you. It's not the right one for your job. And then we get to the point, okay, we just went through all this, like looking under the hood and so on, and why should you care about that? My point is not about avoiding the work or rendering or the performance itself. My point is, it's easier to understand how your app works. And you might think I'm biased. I probably am, because I work at SolidJS. But I have an exercise for you folks. First of all, just a little parenthesis. There are two kinds of developers. The ones that use console log. Can I have a show of hands? And the ones that don't like raising hands. Because you all use console log, I know that. So let's take an example here. I have this little component that you've seen in the wild. This code doesn't exist. There's no like make data on any framework. I just don't. So this code is abstract to a point. It can, at this point, if I replace make data with the framework's core methods, it can either be React or Solid. So this code itself doesn't tell you if it's supposed to be virtual DOM or not. But let's do this little exercise. So I have this onClick event, and I have the initial data of 0. And right after I dispatch this update data, I'm going to log. I'm going to log my state, which is the data. I'm going to log a derived state that is just taking, as soon as I update the data, it's going to double it. So it's a number. And I'm going to log whatever is in the text above. So another show of hands. Who think that this would be more intuitive if I'm logging this? And who would prefer that? Like, if I'm updating the count to 1, double should be 2, and so on, right? So if you're like debugging this kind of component, and you don't know how it works, and you're updating the data and you want to see it, if you're running like a playwright test or Cypress test, or if you're debugging in the browser and you say, okay, I'm going to put a debugger right there and I'm going to log what data I have to see if my logic is working. These are like the two main cases. There's a little bit more nuance than that because there's a whole like heuristics inside the frameworks about batching, the re-renderings and so on. But let's take a look at this little example. So here, I'm using StackBlitz, and I have this little app. And what I do is, can you see it? Do you need to make my font bigger? Is that OK? Up in the back? Huh? Bit bigger. Let's see. Oops. It's making other stuff bigger. How do I do this? User settings, font size, I think. Should be this. Does it work? Nope. Great. OK. Now it works. Cool. So I have this component. This is a React just for the sake of example of what's a pooling system. So I have a state, and then I'm setting this double count. So this is like usually how I used to write React. There are other stuff about here we can talk about, like that we are not using a contract here. We are actually setting it imperative. They are not derived and so on. But let's ditch that part. And what I'm doing here is I'm setting the count, which means it triggers this little effect because it depends on the count, and then it sets the double count, right? And then as soon as I do this, I'm going to log what's the value. So now I do this, and I get a 0. But my state is actually 2, and so on. And it makes it a little bit harder because if I do this, and you say that, OK, you can do that in React. You can do that on other frameworks as well if you have like a tick or flush sync or something like that. But with that, you're already dealing with like the framework specifics. And then if you go to a eager signal implementation, we're going to talk about eager and lazy in a minute. What you get is pretty similar in this case. So we are creating a state, and we are making this derived. So there's no use effect and anything like that, because as I mentioned, we can subscribe automatically, because this thing is a function call. So every time count updates, it automatically says, OK, everything that depends on that count runs that again. So I have the derived state, so I cannot manually or imperatively update double count. It's always connected to count, which makes it a little bit easier to reason about already. But now, because it's eager, and it updates immediately, if I do this count thing, my log is exactly what I'm seeing. And that makes it super easier to debug and to reason, especially if you're reasoning to someone that every now and then you get somebody that's not as familiar with how your framework works under the hood, and then they can intuitively understand how your app is actually sticking. Awesome. So let's get back to it. So now you're all Signal experts. And great, you graduated. And now let's talk about the hype. So Nicola was yesterday talking about what's coming to TC39. This one, unfortunately, is not one of them coming this year. But there is a proposal happening, which means that, remember that first graph that I set up, that I showed about all the frameworks that are adopting signals, TC39, realized that and is responding to this by creating this proposal. The proposal, I think it's going to take a little longer than a year or two because there's a lot of stuff to implement in the language to make it agnostic, to make it capable to support all flavors of signals and so on. Talking about flavors of signals, I mentioned lazy and eager before. So there are two ways of dealing with signals, in this case, roughly speaking. The first one being the lazy one, where in the lazy one, the bottom component, the child updates, it's going to communicate its parents, and then the parents communicate the one that's supposed to handle the data. Whenever that one updates, it's going to cascade down, because then it notifies each one to pull and so on, and then finally you get that one updated. Lazy is really good to prevent, there's like a common problem in signals, like it's like the ultimate test for signals is when you have diamond, where you have a diamond problem that there's another component between the green and the green and the pink one. And so your system needs to be able to update them in the right timing and in an efficient way that doesn't provoke state tearing. By doing this cascading up with the update and then cascading down incrementally, you get it, you solve this problem way more easier than the eager version. In the eager version, you get the update, and then they automatically already pull it. So you get an update, the blue one immediately updates, the green one immediately updates, and then it cascades down. So it goes from the data source down, notifying the updates, and they pull the updates. So why do we have this difference? Because they perform differently in different architecture kinds of things. So a lazy model is way easier to support very deep architectures. So if you have like deep nesting, a lazy model tends to consume less memory and to work faster. While you have something that's wider, the eager model tends to be faster and to consume less memory, tends to. So the question is, to which flavor of signals works best for you, is to understand how your dependency graph, in terms of data, not node modules, how your dependency graph works in your app, if your app is deep or wide. Most likely, your apps are wide. In the DOM model that we have is wide. So you have, like, for example, a navigation bar that has your user, name, and picture, and then somewhere in the middle, you're showing the name again, and so on. It's not like deep nested. It's not like some other state depending on the name, like 5 children down. That's not that common. So let's take a practical look about how each one of the fine-grained frameworks behave in terms of eager or laziness. So we have Quick and Angular with their implementation that's a little bit towards the lazy side. And up until recently, like Svelte and Vue was somewhere here because they were a little bit like that. And Solid has been, for the past 6 years, on the eager side. And recently, with Svelte Runes and Vue Vapor, they're using the same model now. So in terms of signal implementation, these ones have pretty much the same kind of implementation right now. As soon as Vapor and Runes, I think Runes are already unstable branch, not entirely sure. But as soon as Vapor is out, they're going to have a very similar model than Solid 1. OK, so a quick recap. We saw about the pull, push, and push-pull architecture models. The reason why we do it is, first, it's DX. It helps you write more. It's more code that's easier to reason about. Oh, oops, I did. Yeah, sorry. And yeah. And because that, it's easier to debug your code, and as a consequence, it tends to be more performant. And now my slides gave up on me. So the last thing that I want to, and then we have the eager, and my slides went haywire. So we have the eager and the lazy versions of signals, but the question that I want to leave you with is, are signals worth the hype to you? Thank you very much.